talk about some right triangles, and we're going to talk about finding the area or finding missing sides of a triangle using Pythagorean Theorem. It's on 248 in your book, so if you open your books and you'll read Theorem 75, make sure you get that down in your notebook. It says the square on the hypotenuse of a right triangle is equal to the sum of the squares of the two legs. So that is it in word form, but simply all that means is that a squared plus b squared equals c squared. And you can use this formula, Pythagorean Theorem, to solve for missing sides of a triangle. So I've got first, over here I have a right triangle. You can only use Pythagorean Theorem if it is a right triangle. How do you know it's a right triangle? It has a 90-degree angle, and this little box right here tells us that that's our 90-degree angle and that it's a right triangle. So according to Theorem 75, this side squared plus this side squared equals this side squared. And as with anything else that we do, you can solve for a missing side if you have two or three. But first, I want to make sure that you realize how to pick out the hypotenuse, okay? We've talked about this several times. The hypotenuse is opposite the right angle, okay? So this is the right angle. The hypotenuse is the side, the long side, that does not touch either side that touches the right angle. It is opposite. So that's important because you need to realize that this is the hypotenuse and that the hypotenuse is always c squared, okay? Now, it doesn't matter which letter you label your sides. You could have B here or A here, or either, you know, sometimes it'll give you another letter in your worksheets. It could be V or U, okay? It does not matter. All that you need to know is that the side opposite the hypotenuse, opposite the 90-degree angle is the hypotenuse, okay? And that's always c squared in our formula, okay? So I have a little example here to kind of work through with you. We know that this is 3 and this is 4, but we do not know what this is. Now, this is the right angle, so that means this is the hypotenuse. So if that's the hypotenuse, then this is our c squared. Now, this can be a squared, this can be b squared, or this can be a squared and this can be b squared. It does not matter. So I'm just going to do mine ab, okay? So to solve, you simply plug in your numbers into the formula, and at the end you take the square root of c to get your answer. So here is our formula. A squared plus b squared equals c squared. A is 4, so 4 squared. B is 3 plus 3 squared equals c squared. We do not know c squared. That is what we are solving for. So go ahead and square your legs. So 4 times 4 is 16 plus 9 equals c squared. Add 16 plus 9 is 25 equals c squared. Can I stop there? No, because I have c squared, I have to have only c. So take the square root of both sides to cancel out the square, and you will get c is 5. So our missing leg, our hypotenuse, is 5. Now, if you look on down the page, on page 248, you'll see corollary 75(1), which is kind of the converse of the Pythagorean Theorem, okay? So I'm going to read it to you, but then I'm going to tell you practically what it means for you, because sometimes the words are just a little wordy. Okay, it says, the square on one leg of a right triangle is equal to the square on the hypotenuse diminished by the square of the other leg. What does that mean? Okay, so this is Pythagorean Theorem. This is the square of the two legs equals the square of the hypotenuse. All that means is you can solve for either leg by subtracting whatever leg you have squared, okay? So your formula changes around just a little bit. You're now, on this for example, you have your hypotenuse. It's 5. You're not solving for it. You have a leg, which is 3, but you do not have the other leg. Let me go ahead and just label it this way. I'll show you here. Oh no, that's right. Okay, so a squared equals c squared minus b squared, okay? So this is c, this is b. I don't know a squared, that's what I'm solving for, okay? So the whole purpose is you're just changing your formula around a little bit. I'll show you how that's derived, okay? A squared plus b squared equals c squared. Okay, we know b squared, we know c squared, but we don't know a squared. That's what we're solving for. So what do we have to do when we're solving for a variable? We have to get it by itself. Okay, so right now this b squared's in the way. I'm going to subtract the b squared on this side to kill it, and then I'm going to subtract it over here. You cannot subtract a b squared from a c squared. Y'all know that. So you're going to have a squared equals c squared minus b squared. Now, this is the formula that you use if you are missing a leg and not the hypotenuse. If you are missing the hypotenuse, you use Pythagorean Theorem. If you are missing a leg, you use Corollary 75-1, which is this, okay? It does not matter which leg that you are missing, you still use this, okay? So I'll show you how this works, just like I did over here. Okay, I don't know a squared, there's a blank here. So a squared equals the c squared, which is 5, c squared minus 3 squared, okay? Minus your b squared. Now, go ahead, do your exponents. A squared equals 25 minus 9, okay? 25 minus 9 is 16. Can I stop there? No. It's a squared, I need just regular OA. Take the square root to cancel out the square, and you're gonna get A equals 4. Whoa, am I right? I'm right, okay? So, if you are solving for the hypotenuse, your hypotenuse is always C, okay? And you're gonna use your regular formula. If you are solving for a leg, you're gonna use this formula.